Welcome to the U.S. Environmental Protection Agency's presentation to explain the proposed cleanup plan for the Milford Contaminated Aquifer Superfund site. The Milford Contaminated Aquifer site is in Milford, Ohio. My name is Adrian Palomeke, and I am U.S. EPA's Community Involvement Coordinator for the site. This presentation has three main purposes. First, to explain EPA's recommended cleanup plan for the site. Second, to provide information on the status of the site. And third, to solicit public comments on the proposed cleanup plan. A transcript of this presentation is available on EPA's website at www.epa.gov/superfund/Milford-Aquifer. There are 5 ways you can submit comments regarding the proposed cleanup plan. You may submit comments online at EPA's webpage at www.epa.gov/superfund/Milford-Aquifer. You may submit oral or written comments during the virtual public meeting on December 15, 2021. You may also submit a written comment by mail to Community Involvement Specialist Meg Musa at Tetra Tech Inc., 12334 Valley Vista Drive, Chesterland, Ohio, 44026. Additionally, you may send comments via email to EPA's Community Involvement Coordinator at palomeke.adrian@epa.gov, or you may leave a verbal comment by voicemail at 312-353-6646. Comments must be received or postmarked within the 30-day comment period, which runs from December 8, 2021 to January 7, 2022, to be part of the official public record. U.S. EPA's Remedial Project Manager Dave Frank will now share with us background information on the site and explain the proposed cleanup plan.
Thanks for the introduction, Adrian. The Milford Contaminated Aquifer site is located in Claremont County, Ohio, in a suburban area with mixed residential and commercial industrial properties. It is located approximately 15 miles northeast of Cincinnati, Ohio. The red outline shows the area that encompasses the historical investigations at the site. Volatile organic compounds, or VOCs, were first discovered in the Milford municipal wells in 1986. VOCs are contaminants that evaporate in the air. Investigations by Ohio EPA and EPA indicated the likely source of the VOC contamination was to the east of the well field. In 2011, the site was added to the National Priorities List, or NPL. Additional investigations point to a former dry cleaner at the Baker Feed property as the source of tetrachloroethene, or PCE, contamination in the groundwater. At this time, the city of Milford uses an air stripper for treatment of municipal water to remove VOCs from the groundwater. Private drinking water wells are prohibited in the city of Milford. What are the risks at the site? As part of the site remedial investigation, EPA conducted human health and ecological risk assessments to determine the potential risks to human health and the environment from exposure to site-related contaminants. The risks and pathways that will be addressed by the cleanup include human health risks from people ingesting or touching contaminants found in the groundwater. As I mentioned, the contaminants of concern at Milford are VOCs, which are contaminants that evaporate into the air. These include PCE and trichloroethene, or TCE for short. TCE is a degradation product of PCE, meaning it naturally breaks down from PCE into TCE over time. These chemicals have been found in groundwater at levels above the safe drinking water levels, known as maximum contaminant levels, or MCLs. PCE has been detected at 760 parts per billion, or ppb, and TCE at 35 ppb. The MCL for both PCE and TCE is 5 ppb. The investigation did not find evidence of vapor intrusion currently happening at the site. Vapor intrusion occurs when there is a migration of volatile chemicals from contaminated groundwater or soil into an overlying building. Here you see the extent of PCE contamination in groundwater, the PCE plume. The blue shaded area shows where PCE has been found in groundwater above the MCL of 5 ppb, also sometimes described as micrograms per liter. And here we see the extent of TCE contamination in groundwater. It's a slightly smaller area and located within the PCE plume. As shown in the previous figures, groundwater contamination is present from the Baker Feed property at the intersection of Baker Drive and Lila Avenue west to the Milford wellfield. The depth to groundwater at the Baker Feed property is approximately 45 feet below ground surface and ranges throughout the area, between 18 and 65 feet below ground surface. The Ohio EPA and EPA investigations determined that the former dry cleaner at the Baker Feed property is the source of contamination. The dry cleaner was in operation between 1957 and 1967. Soil sampling during these investigations found the highest levels of PCE along the southern and eastern edges of the Baker Feed property. As previously mentioned, the investigations did not find evidence of vapor intrusion at the site from these chemicals. The vapor intrusion pathway was evaluated by taking soil vapor samples from locations within the source area and the plume. Soil vapor concentrations in the shallow soils did not exceed residential or industrial commercial criteria. However, out of an abundance of caution, additional soil vapor sampling will be conducted to verify that seasonal changes, such as higher or lower groundwater levels, do not cause soil vapor concentrations to increase to levels of concern. In addition, a screening level ecological risk assessment concluded that animals present in the Little Miami River are not at risk from surface water and sediment exposure. Here we see a conceptual site model of the site. The figure shows the source area, the Baker Feed property, and contaminants moving downward into the groundwater. The groundwater flows within a sand and gravel aquifer, the same aquifer from which the city of Milford draws its water from, towards the Little Miami River. Drinking water for the area is sampled and treated before distribution to ensure it is safe. This slide shows the cleanup objectives for the Milford site. They include restoration of the groundwater to its beneficial use, prevent current and potential future residents and workers from exposure and risk to potential pathways, and prevent migration of the VOCs in groundwater to the municipal well field. EPA assessed different cleanup alternatives to address the source of groundwater contamination in the feasibility study. A total of 6 cleanup alternatives were compared against each other using specific evaluation criteria. A no-action alternative is presented as a comparison. Based on this comparison, EPA selected a recommended alternative to address the contaminated groundwater. EPA's recommended alternative will be discussed later in the presentation. Each cleanup alternative includes some common elements that would be part of any selected remedy. These elements include reinforcement of existing institutional controls to prohibit private potable use of groundwater until the cleanup objectives are met, verification that all properties within and near the plume are connected to the municipal water supply, remedy-specific engineering controls, such as signage and fencing, during construction and operation of the remedy, a pre-design investigation to help assist with the remedy design, and long-term groundwater monitoring. In addition, each of the injection remedies, alternatives 2A, 2B, and 2C, include a permeable reactive barrier, or PRB. The PRB is injected into the subsurface downgradient of the source area and would be an additional measure to further treat contamination. So let's go over the three proposed injection remedies, alternatives 2A, 2B, and 2C. Alternative 2A is targeted in situ chemical reduction, or ISCR, at an estimated cost of $3.6 million. We would physically inject liquid that contains zero-valent iron or some other substrate, to be determined, into the ground at the source area. The liquid is designed to react with the PCE or TCE and degrade them into ethene, a non-hazardous end product. This remedy is expected to take approximately 2.5 years to complete. Alternative 2B is targeted in situ chemical oxidation, or ISCO, at an estimated cost of $2.1 million. ISCO is similar to ISCR, except the liquid injected chemically oxidates the PCE and TCE rather than degrade it, leaving no anticipated byproducts. The liquid would contain an oxidant such as sodium permanganate or sodium persulfate. This remedy is also expected to take approximately 2.5 years to complete. Alternative 2C is a flexible alternative that would be finalized after the pre-design investigation. It includes the ability to use ISCR, ISCO, enhanced reductive dechlorination, or ERD, which works in conditions without oxygen to diminish contamination, or some combination of the three. With ERD, amendments like lactate or vegetable oil are injected along with microorganisms to accelerate the breakdown of contaminants. The estimated cost of Alternative 2C is $3.3 million and is anticipated to take approximately 2.75 years to complete. Alternative 3 is targeted in situ thermal treatment at an estimated cost of $13.6 million. This treatment technology uses a series of electrodes to heat the contaminated soil and groundwater. The heating results in several mechanisms to mobilize the contaminants for capture, including boiling and steam stripping. A contaminant capture system similar to a soil vapor extraction or SVE system is used to capture the contaminants. Specific thermal treatment processes would be selected during the design phase. This remedy is expected to take approximately 1.5 years to complete. Alternative 4 is pump and treat at an estimated cost of $14.9 million. Several extraction wells would be installed to remove groundwater, which would be sent to a new on-site groundwater treatment plant. Extraction wells would be located at Baker Feed, and additional wells beyond the Baker Feed property may be needed, as determined in the final remedial design. At the new groundwater treatment plant, the extracted groundwater would be treated to remove the VOCs. The specific treatment process would be determined during the design phase, but may include some combination of the following: filtration, pH adjustment, air stripping with off-gas treatment, and carbon absorption. As part of the design process, several potential discharge locations would be evaluated. Once treated, water would be discharged into the Little Miami River or the East Fork of the Little Miami River through a newly constructed discharge pipe, or, if sufficient capacity is available, through the existing sanitary sewer system to the Milford wastewater treatment plant. More details about all the alternatives EPA considered are available in the proposed plan and in the feasibility study, which can be found on EPA's webpage at www.epa.gov/superfund/Milford-Aquifer. When evaluating cleanup options, EPA is required by law to consider 9 evaluation criteria, which include things like protection of human health and the environment, compliance with laws, effectiveness, implementability, cost, and state and community acceptance. Based on the 9 evaluation criteria, EPA recommends Alternative 2C, which is the flexible option of treating on-site groundwater by injecting amendments into the groundwater to break down the contamination. Although Alternative 2B is cheaper, it does not provide the flexibility in the event that the pre-design investigation identifies ISCR or ERD as a better option. Therefore, Alternative 2C is recommended. So to summarize, Ohio EPA and US EPA recommend that the Milford contaminated aquifer be addressed by 1. Injecting reagents into the aquifer to break down the contaminants in soil and groundwater. 2. Reinforcement of the existing institutional controls on groundwater use. And 3. Monitoring the contaminants in groundwater until cleanup objectives are met. The total estimated capital cost of the remedy is $2.75 million. And the total cost that includes 30 years of operation of the remedy is estimated at $3.3 million. I will now turn the presentation back to the site's Community Involvement Coordinator, Adrian Palameke, to explain the next steps in the process and provide some final information.
Thank you, Dave. For next steps, we invite the public to send us comments on the proposed cleanup plan. After the comment period ends on January 7, 2022, EPA will review and reply to the comments received in a responsiveness summary. After that, the agency, in consultation with Ohio EPA, will select a final cleanup plan. The agency will document the final cleanup plan in the record of decision, which will include the written response to the comments received. After that, the cleanup is designed under what EPA calls the remedial design phase. And finally, the cleanup gets implemented. For more information about the proposed cleanup plan, please visit EPA's webpage at www.epa.gov/Superfund/Milford-Aquifer. You can also contact US EPA's Remedial Project Manager, Dave Frank, at frank.david@epa.gov, and US EPA's Community Involvement Coordinator, Adrian Palameke, at palameke.adrian@epa.gov. If needed, Ohio EPA's Site Coordinator, Leslie Williams, is also available at leslie.williams@epa.ohio.gov. Please remember that there are 5 ways to submit comments by January 7, 2022. You may submit comments online at EPA's webpage at www.epa.gov/Superfund/Milford-Aquifer. You may submit oral or written comments during the virtual public meeting on December 15, 2021. You may also submit written comments by mail to Community Involvement Specialist Meg Musa at Tetra Tech Inc., 12334 Valley Vista Drive, Chesterland, Ohio, 44026. Finally, you may send comments via email to EPA's Community Involvement Coordinator at palameke.adrian@epa.gov, or you may leave a verbal comment via voicemail at 312-353-6646. Thank you for your interest in the proposed cleanup plan for the Milford Contaminated Aquifer Superfund site. We look forward to your comments.